Alright guys, today we're going to look at some other limits that when we plug in our value, we're going to get an indeterminate form. But instead of doing some basic algebra and things like we've done before, these are actually, the top four limits that are shown are actually four special trig limits. And what those are if we have a limit in that form, without even doing any math, we can just find my answer there. So we've got two that involve sine and two that involve cosine. In all four of those limits, if I were to plug in 0 to the original equation, I would get 0 over 0 as the values. Alright, so what I need to look for then is whenever I have limits like this, if I can put them in a form like this limit, where I have the sine of something and the argument is the same as what I'm dividing by, I'll get 1 as an answer. And then same thing for cosine. If I have 1 minus the cosine and the argument matches what's at the bottom, then I'll know that I can get a limit of 0. Alright, so this, for example, this one down here, I have the limit as y approaches 0 of the sine of 4y divided by 4y. So since I'm taking the sine of 4y, the 4y actually is my argument, and the 4y matches at the bottom, that's my x. That takes the place of the x. So this is the same as that first limit. So that means the answer to this limit, without even doing any work, is just 1. Even though if I were to plug in 0 for y, I would have gotten 0 over 0. Now, not all of our limits are going to be that simple, so we need to look at a couple of properties to help us figure some of these out. So both these properties are pretty simple to understand, and you honestly have been doing them without really knowing it's technically a property. So the first one, anytime I have a limit as x approaches some constant number, and I have some constant number multiplied by a function. It doesn't matter what it is. The example here has a 4. That can be any number. I can move that 4 to the front and multiply it out in front and still take that limit. So for example, what I can do instead is have 4 times the limit as x approaches c of f of x. Now what this would look like in work would be if I were to have something like the limit as x approaches 3 of 7x. That's going to be equivalent to 7 times the limit as x approaches 3 of just x. Both of those, no matter which way I work it out, I'm going to get 21 as an answer. Okay, now this next one down here, if I have the limit as x approaches c, and I have two functions that are multiplied together, what I can do here is I can actually separate these and find both limits and multiply them together. So that's going to be equivalent to the limit as x approaches c of the first function times the limit as x approaches c of the second function. And this works with multiplication as well as a couple of different things like adding or dividing and things like that. Okay, but multiplication is the one specifically we're really going to be using today. So something like that would look like, let's say I have the limit as x approaches 9 of the function x times the square root of x. Well, that would be the same thing as finding the limit as x approaches 9 for x, and then multiplying that by the limit as x approaches 9 of the square root of x. No matter what, either way, I'm going to be getting 27. So using those properties and those special trig limits, we can evaluate some limits like this. And remember, we always want to start by just trying to plug in that number and seeing if I get a value. So if I just plug in 0 to this equation, I have the sine of 3 times 0, which is the sine of 0, which is 0 over 0. Okay, so obviously we can't just plug it in. We need to try to make this look like one of those special trig limits. So those special trig limits, I know if I have the sine of 3x as an argument, then if the bottom has a 3x, then I can get that special trig limit of 1. So in order to get that 3x in the bottom, I need to multiply the bottom by 3. Well, we know if we multiply the bottom by 3, we also have to multiply the top by 3. And with that property we just learned, 3 times the sine of 3x over 3x is the same thing as if I move that 3 out to the front. So this is the same thing as 3 times the limit as x approaches 0 of the sine of 3x over 3x. And I know that for this limit over here, because my argument, my 3x, is the same as what I'm dividing by, that's just 1. So all I have here is 3 times 1, which works out to be just 3. All right, my next one, again, we're going to use a similar strategy, but we're also going to incorporate that second property. All right, so what I'm going to do here is I have the limit as x approaches 0 of sine squared 3x over sine squared 7x. And again, I want to try that same thing. I want to make sure I get 0 over 0, which I do when I plug it in. Now remember, sine squared of 3x, that does not mean the sine of 3x times 3x. Remember, I'm squaring, when the squared is written there, I'm squaring the entire quantity. I'm doing the sine of 3x, and I'm squaring that. So I'm doing the sine of 3x times the sine of 3x. So on this one, I'm just going to rewrite this a different way. Sine squared 3x, like we said, that's the sine of 3x over 1 times the sine of 3x over 1. And then I also have 1 over the sine of 7x and 1 over the sine of 7x. Now, with that second limit property, what I can do is I can find each of those limits individually and multiply them together. So I would have the limit as x approaches 0 of the sine of 3x over 1. And I would have the limit as x approaches 0 of the sine of 3x over 1, and I would keep doing that for each one. And for each one, I'll evaluate these just like I did in the one before. Now, I'm not going to rewrite this every single time. I just wanted to show it to you guys once so you can see what we're actually doing. But I'm going to go ahead and erase this to make some space. So what I'm going to do is I'm going to evaluate these just like I did before. So that last step, what we did was the sine of 3x. In order to make that my special trig limit, I multiplied the bottom by 3x to match that argument. And if I multiply the bottom by 3x, I also have to multiply the top by 3x. Same thing here. Multiply by 3x, I have to multiply by 3x. Now in the next one, if I have a sine of 7x at the bottom, I need that matching argument, which means the top needs a 7x. But if I multiply the top, I also have to multiply the bottom. And that works on both of them. Now what's going to happen here, remember, we're evaluating each limit of each of these that are multiplied together. So if I evaluate this first limit is going to be 3x times that limit, which is 1. So I end up with 3x. And the same thing is going to happen again. That's going to be 3x times 1. Then I have that limit working out to be to 1. So instead of having 7x, I actually have 1 over 7x. And then the same thing on the last one. So when I actually multiply this out together, I get 3x squared over 7x squared. My x squareds go away, so that whole limit, and I multiplied my numbers wrong, should be 9x squared over 49, x squared. My x squareds still cancel out, but instead of 9 over 7, I have a 9 over 49. And that's my final limit. Alright, so we're going to do two more that use those same kind of strategies. So next one, I want to look at the limit as x approaches 0 of sine squared x over x. Again, if I plug in 0 for x at the very start, I'm going to get 0 over 0. So there's something I'm going to need to do to change this equation. So again, I want to try to make it resemble one of my trig functions. So what I could do is sine squared we know is sine x times sine x, and it's divided by x. Now remember, either one of these, if I'm splitting it up, can be divided by x. I'm still going to get the same thing. And I know that limit over there on the right is going to be 1. So now all I need to look at is that first limit. And that first limit can again be one of my special trig limits if I multiply the top and bottom by x. So what's going to happen there then, I'm going to have 1 times 1 with an x left over. So all I'm going to have here is x. But remember, x isn't my limit because I'm looking for my limit as x approaches 0. So now I can plug in 0 for x and I get my actual limit, which is 0. So I have 1 times 0. Alright, next one uses that same idea. So what I'm going to do is I have the limit as h approaches 0 of the sine of 4h over h cubed. And again, I'm going to do this the same way. I'm going to try and split that up. Now, I cannot split up the argument. I have to keep that 4h there. I can't really mess with that unless I use some of my half-angle properties or double-angle properties or something like that, which we're not really going to get into right now. So if I have the sine of 4h, what I'm going to do is I'm going to take that, and I'm going to keep one of those h's with it, because that makes it really close to that special trig limit. And then I still am left over with a 1 over h squared. So now looking at my properties again, that sine of 4h can be one of my special trig limits if the bottom gets multiplied by 4, which means my top gets multiplied by 4. So that means that limit over here is 1, so I've got 4 times 1. Then I have that times 1 over h squared. Now the problem here is I still need to plug in 0 for h. So I'm going to end up with 4 over 0. And we know if we have a number divided by 0, that's very different than 0 over 0. That means I've got an asymptote of some sort there, so that limit does not exist. So remember, a number divided by 0, that limit doesn't exist. It's very different than 0 over 0. Alright, the last one here is actually straight off that homework assignment. It's going to help you guys a little bit because it's going to remind us what we did last semester some. So if you guys remember, last semester we learned some trig properties. And one of those properties that we learned was that sine squared plus cosine squared is equal to 1. And we know that we can rearrange that property however we want to. So if I want, I can subtract a cosine squared, and I get that sine squared x is the same thing as 1 minus cosine squared x. So I can replace that 1 minus cosine squared x with just sine squared. And that's what I'm going to do. And now I'm going to try and split up this limit in a different way. So what I'm going to go ahead and do is I'm going to change this to sine of x over x times the sine of x times 1 over the sine of 2x. And then what I can also do here is I can figure out what I need to multiply these by. So one of the things I can do here is this middle limit. I know needs to get an x on the bottom, which means if I need to multiply by an x at the bottom, I got to multiply by x at the top. And I know that this limit over here, I need a 2x at the top, then I have to have a 2x at the bottom. So what's going to happen, I'm going to be left with a limit of 1 times x, because that limit is 1, times 1 over 2x, because that limit is 1. When I work that all out, my x's are going to cancel out, I'm going to be left with just my value, which is 1/2. Okay, so that's the last new thing about limits before your next test. So just be familiar with those special trig limits because they can help you out when you keep getting some indeterminate forms.